In this video, we're going to cover some aspects of database security. So your organization has invested time to sort of organize, collect all its data, and this has been a difficult and time-consuming process. And so you've got to view your information as an asset. Um, and so it's like any of your assets, it should be uh, protected. And so that's what we want to do here. How do you make your database secure? Okay. And one of the first things you do is you establish a security policy. So you have a team or a designated person or a team to sort of recognize that the database is an important asset and it's worthy of securing, and then you start to put together sort of a plan, what you think is important, what you're going to, how you're going to invest, what you're going to do if something goes wrong, and so on. Um, One of the reasons that you put all your information into a database was to make the data accessible to the right people within the enterprise, and maybe some external people, I don't know, customers or something. Um, And so you want to have to do some balancing act of accessibility and security. To lock everything down sort of defeats the purpose, but to have it completely open up doesn't work either. So we need to do this thoughtful process of figuring out uh, how to do it, and that's the security policy. So it ought to be written down so that and sort of and people made aware of it and publicized. So it should be um, established, written, and put in a place where people know where it is and can access it. But it also has to be flexibility. We're talking about technology after all, and it's always changing. Everything's changing radically and fast right now with AI. So sort of a security policy has to be flexible and recognize these changes. Um, so some of the things that you should have in a security policy are who has access to what information. So what information is in the database, who has access to it, and so on. So like in a university, I may need access to sort of what a student is taking or something like that, but I don't need access to their financial aid or the salaries of faculty and staff. So that needs to be sort of spelled out. Who has what information do we have? Who has access to it? Um, and then the policy should describe the measures of what we're putting in place to keep the data safe and what are the penalties if somebody violates it. Um, and then we need some process of evaluating, it's nice to have a policy, but is it effective? And then we need to educate the users so that they are aware of the issues and the policies and so on. Okay. So things to think about: integrity. So the data is supposed to model a situation and it should properly model that. So we don't want the data, we want to protect the data from any kind of corruption, whether it be accidental or intentional. We want to keep in mind availability. Um, all having gathered all this data and organized it is not very useful if it's not available to the right people in the organization. Confidentiality, this is the sort of the company's data, and we want to make sure that we make available some of the data, but we want to also protect the data from users who ought not have access to particular kinds of information. The flip side of that is privacy, and it may be the users that we need to protect. So we might be selling a product, and so we want to keep some information about the product. No, maybe we don't want people to know uh, what it costs, how much profit we're making. Um, on the other hand, that might be bad for competitors or something. Um, on the other hand, there's the privacy. So, like our customers sort of put in some data to order our product, and then they have a right, they have some expectation that we are taking care of their data that they sort of gave us for for the purposes of ordering something. And we have to worry about theft and fraud, sort of like, are people stealing the information? And this is, again, theft and fraud of data, of information. So are we uh, protecting our data from it being stolen? Are we protecting our data from it being um, misrepresented? So we look at the database, we see how it's being used, we look for the threats, and there are, you've got to worry about intentional threats, hackers trying to get in, people who want to steal something or just disrupt something, or things that may be accidental. What if there's a fire? What if a server goes down? Things like that, a flood, we're in the server room. Um, So we have to worry about the threats, the things that, might go wrong. Um, if one person uses another person's uh, means of access. Um, what if somebody changes or copies data that they weren't supposed to? You have people writing programs. What if the programs are altered? Um, what if the policy itself is not adequate? Then what are you going to do? What about people sort of eavesdropping on you electronically? Are people seeing the traffic and knowing what's going on? Um, what if hackers get in? What if somebody's blackmailing you? What if somebody put a trapdoor in the system? So that means they have a means of access. So, that not going through the proper channels so that they might still have access if they are leave the enterprise, or they might just have a way of accessing the system without it being sort of logged what they did. um, you could have people stealing the data or the programs or the physical equipment, um, and we don't want to, and we're always balancing availability, accessibility, and security, and we want to make sure that we don't give more access than we should. Um, Other possible threats. What if there's a staff shortage or a strike? What if we don't have enough training of staff? What if people are looking at the unauthorized data, things they're not supposed to see? What about um, people just disrupting uh, our signals, like if we're trying to communicate with the outside world? What about power loss and power surge and fires and so on? Um, just physical damage, bad cables, viruses, sort of all sorts of possibilities. We should, think about them all. Usually, you know, if an enterprise is large enough, you have somebody who, at least one person, maybe more, sort of specializing in security. So here's a diagram of the database, the actual place where the data is stored, then the sort of system of networks that is used to access it, and then the sort of, I don't know, I'll call it the client machines where actual users of the database work. So um, we have the hardware and software of the actual data in the database. That's that sort of cylinder sort of over there on the right. And then we have the network by which it's accessed, and then the individual machines of the clients of the users. And so there's hardware and software and people at all those levels. So you've got to worry about, what could go wrong with the hardware, what could go wrong with the software, what could go, what other people know what they can and can't do, and then have we put in the measures to make sure that is true. That brings up measure or countermeasure. So we figure out what the threats are, and then we put something in place, some action to try to figure out, to prevent or figure out what we will do if the situation occurs. So we'd like to prevent it, but of course we should also have as part of our policy, here's what we're going to do if there is a violation. Okay. So again, we have the level now, it's sort of more vertical. So we had that cylinder at the bottom now, the database, and then we have our access to it. And part of our measure will be uh, authorization. We're going to be asking who these users are and are they the right users? Do they have access? We're going to have a firewall where we monitor what's coming in and out of the system, and then is it appropriate for what's coming in and out to be sort of directed toward our database. We're going to use encryption. We're going to sort of make the data and the commands that we're using to access the data encrypted so that they are not sort of recognizable to the sort of the outside world, to the eavesdropper. Okay. One of the important concepts is authorization. You want to sort of define your users. I have different levels of users, but then even at the same overall level, they might have access to different information. So we're imagining that this is like a user, and not maybe the database administrator. So the database administrator may be involved with the the data control language and the data definition language, creating the tables and then deciding who can access them. So this authorization is done with the data control language, but the users you're talking about typically are going to be working in the data manipulation language of SQL. And so the four main verbs of the data manipulation language are select, update, insert, and delete. And so you can sort of go at a very fine level, um, and say, do they have access? Does a user have access to a table? Do they have access to a field? Can they select? Can they update? Can they insert? Can they delete? What verbs are they allowed? What tables? What field? What columns? So there's a fair amount of specificity that can occur. And this is all done with in the data control language. And the key verb there is grant. You sort of grant some permission. So authorization is what a user is allowed to do. So you can do that in this sort of binary world. One way you can do it is just have this sort of set of 4 bits, and you can have a bit sort of saying, am I allowed to select? Another bit saying, can I update? Another bit saying, yes or no, can I insert? And yes or no, can I delete? And so it gives you a fair amount of control if you use it. So we may say that somebody in uh, human resources who like brings new employees on board, that they have ability to insert and maybe update, but but they may not be able to delete, or they may not be able to touch the salary field. Like they bring the person in, but they don't have access to the salary. They might not even be allowed to see it. Um, Once you've established your authorization, then you've got to start looking into authentication. What, how, so we said this user can do this thing, but how do we know this user is who they say they are? And that brings up the idea of authentication. We are trying to figure out, uh, is this user the person that we believe that we gave certain uh, authorization to, certain allowed certain actions from this user? But who is this user? Is this user who they say they are? Um, and we'll typically use passwords, but we often have like multi-factor these days. And so, you want either maybe something biometric, something about the person or a device, sort of. So you do a combination of password and it's going to for me to access my email or something like that, then it's going to call my cell and sort of say, was that you? So there are things like that, authentication measures. We have the idea um, in databases of a view. So this is where a way to sort of reconstruct a view of sort of make a sort of a table-like uh, entity, a table-like object that has the rows and columns that a person is allowed to see. So then you sort of start with the tables, and maybe it's just maybe it's one table, maybe it's some kind of join, but you construct this sort of pseudo table out of what the person has access to, and that's known as a view. So that's an important concept in database security. Then we talked about like large scale physical things going wrong, fires and so on, server room floods. So we want to have um, a backup. We want to have a backup so that if something went wrong with the database, then we can get that information, that asset back. And we talked a lot especially when we talked about transactions, that we like to have this consistent state that the database should have like values that make sense within the enterprise. So it should be in a consistent state. So we need to be able to restore the database to a consistent state. Um, Sometimes you want a different kind of medium. Um, so a disk or a tape, something that you can sort of save that data and sort of put it in a different place, a different sort of physical place, a different location on a campus. But you might also just take your data and with encryption and all that going on, and just sort of send it someplace else entirely in the world. This is can be called data vaulting. You're going to take uh, take the data, take all the tables and the relations and all that good stuff, all the and just sort of like have a copy of it someplace else, so that if there's uh, a failure, a hardware failure, any kind of theft, any kind of physical damage, fire, flood, what have you, the data can be that data in a different place can be protected. You want to do this with using uh, periodic backup. So the data is changing, so you want to have this done fairly often, and you want to work with encryption so that like this data that you haven't created a threat by you have now you have this copy someplace else. So you want to make sure that that's not a threat, that's not vulnerable. And then this brings up the idea of cloud so that you can use, there are companies that they're not your company, but you sort of like rent their service, and so they maintain uh, places where they might keep keep the whole database for you, or they may keep a copy of the database for you, and then um, these larger enterprises can sort of give you what you need without you having to have maybe the local expertise to do all these things. So you can sort of put some some uh, aspect of this up into the cloud. Um, you are making these backups and maybe either locally or up in the cloud or data vaulting. Um, but it's a transactional database, and so things are also changing. And so we should be keeping track of the transactions so that when you restore, like something went wrong and you need your backup and you need to restore, you would also like to have this log file that says what transactions took place uh, since the restore, so that you can get back closer even to the point up at which you lost things. So that is sort of logging the transaction, be able to sort of backtrack and see what's happened. And that's it so far. Another one to follow where we will sort of dig into a little bit of uh, fire encryption and then firewalls. So that is to come. That's it for now. Thanks for your time.